bestsellers. Stu is W0STU, not hard to remember. And he's going to talk about your first HF station today.
Can I stand up now, Mike?
Yes.
You said everybody got to sit down. Oh. Okay. Howdy again, everybody. Have you enjoyed the day?
Yes.
Have you learned anything?
Oh, yeah. Oh, yeah.
Then we have achieved our goal. So we can just go home now,
And
right?
the food was good.
And the food was good. The food was excellent.
No, that's what I learned.
Okay. Yep. 5 minutes? Okay.
I think you're working it on yourself.
Okay, let's see if we can impart a little bit of knowledge and information about HF and how an HF station works, how to build one, how to put together an HF station. How many of you endeavor at some point in the future to put together an HF station if you haven't already? Most of you, yeah, lots of hands there. Okay, well let's see if we can cover some of the basics. We will really kind of only scratch the surface and talk about the basics here today. There's a lot more depth in most of these topics that we're going to talk about, and be happy to talk with you about that offline. And at the end of my presentation, the presentations, all of them for today, will be available on the website, right, Chip? So I've got some references on there on the last slide for you that you can go and just click on to get more information about some of these topics.
Could we find a more stereotypically inappropriate picture?
No, we could not. We could not. This is the only thing that I dislike about this image, though, is it's Schlitz malt liquor. Yeah. Instead of a fine IPA or any more for me, a gluten-free apple cider, hard cider. Okay, let's get started here. Let's see, the big picture. Here is the basic big picture of an HF station. Well, let's do that again. Do you hear that? Yeah, there you go. This is where the big money is. So you got to get a transceiver of some sort that is an HF transceiver. Those little handhelds are FM only. The radios like Bob showed you last presentation here for your mobile or base station are FM primarily, and he talked a little bit about all mode radios, but that's what you're going to need. A radio that can do at least single sideband is the most predominant voice mode on the HF band, so you're going to want that. AM is used a little bit still, and if you're interested in doing CW or digital modes, connecting your computer up to the radio, you're going to need one of these all mode radios, okay? And they are a little more expensive. We'll look at some details on that in a moment. Maybe you can see it. I'm sorry, I made the mistake of using the 16:9 aspect ratio, and this projector just doesn't like that. So over here, there's an outlet. You see that? Somebody can see that. And then you connect up a power supply. It's plugged into that outlet, and it essentially takes 120 volt AC and turns it into 13.8 volt DC, which is routed into your transceiver. That's what you're powering up your transceiver with. Your transceiver operates on DC, that 13.8 volt DC, so you really need one of these or a battery source to power up your station. Coax. Bob talked about coax a little bit. We'll look at that in more detail, but typically 50 ohm coaxial cable you're going to need, and some length of that. We'll talk about what kind of lengths. And then you're going to need some sort of antenna. In this case, I've depicted what is called an end-fed wire antenna. We'll take a closer look at some of those. And you could also do a typical dipole antenna, a wire dipole, like this. For a first antenna, we recommend one of these, a wire. You can do other things. There's certainly vertical antennas that are available on the market for HF, but for the beginning station, we really recommend the wire antennas because A, they're cheap, B, they're relatively easy to install, and C, if your spouse decides you're not going to be in this hobby anymore after you spend all your time on it, you haven't lost a lot and you can easily take it down, okay? So let's take a look. Oh, optionally, you can also put one of those antenna tuners in line to that antenna. We'll look briefly at antenna tuners. We won't dive too deeply into those, but some antenna types and some installation setups are gonna benefit greatly from having a tuner in the little loop here. So let's take a look at some details about each one of these components, and I've kind of got them lined up here in that same sequence on the table. Here's a power supply and a cable that connects to this transceiver, some coaxial cable that you can use to go to a wire antenna. And I'll pass these around as we get into each component that we're going to talk about. So let's talk first about that new transceiver. Okay, Bob talked about this a little bit, I think. But in that all band category, all band and all mode category, there's three different categories, generally speaking. Three different categories of transceivers generally. All band, all mode, all band is one that you will find on the market. And here's an example of FT991 by Yaesu that Bob pointed out earlier. I think there's one back here, right, somewhere?
Yep, it's in the box.
In the box, so you can take a look at that. I think Dan owns this radio also. And very, very fine all mode, all band transceiver. What that means is it operates on pretty much all of the bands in HF, VHF, and UHF domains. And it also operates in all of the modes. Single sideband, FM, AM, digital modes it will accommodate, and it will accommodate CW as well. Another one is that FT857D that Bob mentioned. I have this in my truck as a mobile station. Really great value, nice package, all mode, all band radio. ICOM has a really nice radio, the IC7100, a little different form factor. You can use that as a mobile radio. You can also use it as a base station. Again, all mode, all band radio. It's got a really nice touchscreen display. The interface, they did the interface on this radio really well. So I really like this, the IC7100. The second category, second major category though, is HF plus 50 megahertz for 6-meter band. So what you're sacrificing here is that UHF and VHF capability for the most part, except for 6 meters, 6-meter VHF. But it's got all the HF plus 50 megahertz. So ICOM, here's the ICOM 7300 that Bob mentioned earlier. Has a real nice package from ICOM. And finally, pardon me. And finally, the third category is HF only or maybe limited HF bands. And one example of that is the Alinco DXSR9T. It's an HF only transceiver, no 6 meters, no VHF, UHF. A little bit lower end product in terms of quality and usability, but certainly a perfectly fine transceiver, and you can get on the air on the HF bands very well. Typically, these radios are going to be 100-watt transmit. Almost, I think, every one of these here are, and there are other products. This is by no means everything's available to you on the market. But 100-watt basic transmit, and you could connect any of these to an amplifier if you wanted to go higher power. For an initial station, your first station, we recommend that you just, quote, run barefoot, meaning no amplifier, just the basic output of the station, and that typically means a 100-watt transmitter. Variables among these radios and others are going to be the transmit and receive quality. Receive quality in particular is going to vary pretty broadly across these radios. The support for various accessories. This Alinco product, for instance, I'm not sure that it will easily accommodate digital or CW modes. I'm not real familiar with it, but it has some limitations in that regard. And the usability and features are going to vary substantially. So I mentioned the touch screen down here with the ICOM IC7100. The Yaesu 991 has a really nice touchscreen interface as well. So those things are all going to vary. We can't cover every conceivable feature here in 40 minutes or so. So do some research, investigate online and from the manufacturers and see what features are out there that you want. But these are kind of the basic categories that you're going to be searching within. So you need to settle on, okay, do I want that all mode, all band capability, and that puts me in one market, or do I want that HF plus 50 only for this station because I've got my my VHF and UHF capability on a different radio entirely that I set up last year. So those kinds of personal decisions. Questions about transceiver at all? Bruce?
Do you think initially starting having a screen with a waterfall and all the lights and colors are just zeroing in on audio or recognition of stations and that?
Well, that's kind of a personal preference, and frankly, it may depend on how big your wallet is. You know, how fat your wallet is. I really like the interfaces that these radios offer. And the ICOM here with the waterfall display, they're very nice, and they can help you to visualize the spectrum, what's going on the band. So if you can afford it, and if you think, yeah, I'm going to be in this hobby or in this endeavor of amateur radio for a good long while, and I want to make an investment, I think it's very often worth the money to go ahead and get those nicer quality user interfaces.
I'm a visual type of person. I have a spectrum analyzer with my LFM stuff. And it's always nice, like Stu said, to visualize what's happening on the band as opposed to photos, but it helps to make decisions on who I want to contact based on amplitude and how strong the signal you are. Before you even get to the frequency, I can see who I might want to try.
Yeah, good point. Especially you see the strength of the signal from the amplitude on this display. So those are nice features to have. And
It's more efficient, you waste less time dialing around.
oh wait, you never wasting time on the radio. Wait, that's like oxymoronic right there. Wasting time on the radio, that just doesn't.
Okay, maybe.
Okay, let's press on. Power supply. Your new power supply. Bob mentioned this earlier, and we're going to take a real quick look at these. Here are some examples of a power supply for an HF station or a VHF UHF station. Jetstream 30 amp power supply, kind of a lower end product, about 90 bucks. Here's a nice Samlex 1235, again a 30 amp power supply. And PowerWorks has become kind of popular here lately, Chinese manufactured, and also a 30 amp power supply. So you can kind of see the price range doesn't vary too greatly, and these are all switching supplies. They're lighter than the supplies that have the full transformer in them. This is a variety of Samlex. It's a 1223 model. It's 23 amps output. I'll pass this around. You guys can see it's pretty lightweight, even with that cord on there, to provide 23 amps of current. That's pretty nice. So how much for that 100 watt station that you want to start with perhaps, how many amps of current do you think you're going to need to run that station? 40. 40 at 100 watts, so how much current does that what kind of power supply? How many, do you need this 30 amps or can you do with less? Is that 23 amps enough? Yeah. Here's the way to look at that. For a 100 watt state transceiver, you're probably going to need a very minimum of an 18 amp power supply. It's best to have a little bit of a pad above that, so that 23 amp supply is probably about the lowest you're really going to want to go to. And you remember this, so those of you from our technician class, power equals voltage times amperage, or EMF times current. So if you got 18 amps times 13.8 volts, which is the output of these things, that's almost 250 watts. Why do you need 250 watts for a 100 watts transmitter?
They're not perfectly efficient.
Yeah, that's exactly right. Transmitters are perhaps 50% efficient if it's not a great transmitter, usually a little better than that, but probably can count on 50%. So there's half of your power up in heat, right? And you'll also need additional power for the receiver side and for your controls and displays and so forth to operate. So having a good, good 30 amp power supply, you're pretty safe there for that 100 watt transmitter. It's going to handle it quite well. Any questions about that one, about power supplies? Okay. How about those coaxial cables? Again, we're piggybacking on Bob's commentary on this a little bit. So there are variable types of diameters, like Bob showed the same image here of the RG58, RG8X, and RGU. ARG8U. And I've got some of that LMR 400 right here, just a segment that's got a couple of N connectors. Okay, Bob mentioned the, what's going on here? Well, we looked at this small, medium, and large gauge essentially, and some characteristics that you're going to want to consider are the loss of the cable at the frequencies you're going to operate at. Now, Bob was really concerned about loss with some of these narrow gauge wires here at VHF and UHF frequencies. Are you guys worried about that at HF frequencies or more worried about that? Led, why is that? Why are you less worried at HF frequencies?
Lower frequency.
Lower frequency means
Less loss.
less loss. Yeah, you learned from our technician class, hopefully, that as frequency increases, loss increases generally, no matter what coaxial cable you're running. So you're going to want to consider, though, what is the loss in decibels per 100 foot? That's a typical unit that you're going to see loss communicated in. And this is some of that, again, that LMR 400 cable that Bob indicated was really nice, and it's got N connectors on here. We'll talk about that in just a minute. We'll pass that segment around. Flexibility. Different coaxial cable types will have different flexibility, meaning how limber is this cable. And that's going to be a consideration for you based upon where you want to run this cable to get it to your antenna. If you're going to be going around corners and trying to tuck it into tight places, you may want a more flexible coaxial cable, something like that Belden 9913 that Bob had on his slide. I like using that cable myself. I've got a lot of it running around my house. It's an RG8 type cable and low loss, but it's much more flexible than is this LMR 400. Not quite as good of loss figures as this LMR 400, but still pretty good cable.
Hey Stu,
Yeah.
you gotta watch that, because some of the 9913 has solid conductor, some of it
True.
has stranded conductor, and I think it may be true of LMR 400 variations as well.
Yeah, that's true. There are variations on each of these types, and they do have different flexibility, different loss values. So take a look at the manufacturer's specifications. Look at that Times microwave website for the loss figures. Is a really good resource that Bob mentioned. The other thing you're going to want to pay attention to is durability against weather. It's feasible but less common for an HF antenna to be in the attic. If you do have your HF antenna in the attic, then you're not too concerned about this weather exposure. But more typically, you're going to be running outside to some kind of wire antenna like we mentioned earlier, and your coaxial cable is going to be exposed to the elements. So you've got to consider how durable is that? How resistant to water penetration is that coax? So again, take a look at the jacket type that's on the coaxial cable and make sure that you've got one that is going to uphold against the weather really well. You can also do some things like run it through a conduit to keep it protected and seal up the conduit. Those kinds of techniques can work to keep your coax safe. And what about this sun exposure thing? What's going to happen there?
UV.
Yeah, ultraviolet radiation will, over time, deteriorate that jacket and allow water to penetrate into the coaxial cable. So just accept from the get-go that one day you're going to have to replace that coaxial cable, okay? And plan ahead for that. It's not going to last forever. It's going to last you a few years, and then you're probably going to need to replace that cable to avoid that water penetration. Cost, of course, comes into play. We talked about how that LMR 400 is a bit over a dollar a foot, like $1.20, $1.30 a foot. Other coaxial cables a little less expensive, but around $1 a foot you can kind of use as a wag for how much this run of coax is going to cost you. And connectors. Bob talked about these guys, the PL259 and the SO239 that are a pair that go together. These are, generally speaking, fine for HF frequencies. They perform reasonably well for HF. I know Mike doesn't like them, and this is not what's on that piece of coax going around the room here. But this is what you're going to find compatible, or this SO239, as Bob said, on the back of most transceivers, and the PL259 will fit into that.
Yeah, it's probably worth noting that for PL259, there are good ones out there and there are bad ones out there. So you want to get some from a reputable vendor like Amphenol.
Yeah.
But there's some out there that are not very good. They fall apart. They don't have the dielectric characteristics they're supposed to. So get something from a good, reputable vendor.
Agreed, yeah. You can find these for, 39 cents in some cases on Amazon. Probably want to get one that's a little higher quality.
Is the difference you get bakelite and ceramic in there versus whatever that other jet, like plastic? Is that what makes the quality better?
I'm not sure about that. Shell, are you familiar with the?
No, I'd rather get the ceramic with the gold pins.
Okay.
But for me, Amphenol is the place to go. I wouldn't mind.
Yeah, Amphenol does pretty good, has good quality.
How's it spelled?
Amphenol.
Yeah. Good stuff.
The other difference between really good connectors and lousy connectors is dimensional tolerances from the machining of them.
And that is,
And that
that's
affects
a
that
good point.
SWR.
If you're gonna be putting your own connectors on the coaxial cable, that's huge. Because if it doesn't fit, just, if the jacket doesn't fit inside the connector, you're gonna have troubles soldering and getting things to work right when you're putting your connectors on, so. Good point. This is the end connector that's on that piece of coax that I was passing around. Has better water seal. It's better at pretty much cross frequencies, but particularly VHF and UHF frequencies. But it can be used perfectly well for HF, and it's a really nice connector. This is what I prefer, although you won't find it on the back of most transceivers. You're going to have the SO239 receiver on the back of most transceivers. Okay, for coaxial cable, still seal it up at connection points. And I'll pass this around also. It's this coax seal. You can buy this on Amazon also in a 4-roll package like this. I've got a little bit of it in this roll, and it's essentially a hand moldable seal. You peel it off of this roll and you wrap it around your connector point and then kind of work it and smooth it, and it makes a really nice water seal that lasts forever. And I've still got some of this goo on this antenna I pulled down after 8 years, and it's still tacky, and it's amazing. It's a really, really good product. So I'll pass that around. You can take a look at how that feels. If you want to stick your finger on it, it's okay. Seal at all the connection points that are going to be exposed to the weather. So anything outside or leaving it's going to have water especially around. Use those cables with UV resistant jackets, and high SWR might indicate that. Yeah, moisture in your system. That's one of the first and most common things you want to look for is, okay, did I get unsealed somehow? Because my SWR is showing really, really high. It will really mess up your cable. Okay, and then finally, or at least in the basics here, the antenna. In-fed wires. I really like these antennas, and I use them frequently. You can get in-fed wires as single band antennas, meaning that it works on only one band. It's tuned or it's cut for that single band. And you can also get multi-band versions of these. So I've got a couple of these I'm going to pass around. These particular antennas are they're called NFEDs, F-E-D-Z, by L&R Precision. And I've got this one all wrapped up. This is a 15-meter band NFED antenna. And what you'll find is a little transformer connector on one end. And there's that SO239 connector that I was talking about. And then it's coiled up here, and you've got a little insulator on the other end. So here, I'll start these around, Mike, that one on your side. And this is a multi-band version. I think, Dan, you use this one at your house. This is the NFED's EF quad it's called, and it works on 10, 15, 20, and 40 meters. And you'll see on this one, it's got these little burrs hanging off of it, right? These stubs, they're called. These little got red connectors on the wire, and this is to help tune or get the SWR correct across those different bands. So it's a single long wire with an end-fed transformer connection here, and you just run that wire out and these stubs hang off of it. These antennas are best run horizontally. They work best with horizontal arrangement. You can slope them a little bit, but these stubs hang off of here, and they work best if those stubs are hanging down orthogonal to the run of the antenna, 90-degree angle off the antenna. So here I'll start that one around. You can, with these antennas, just be careful passing around that you don't crimp a wire. That's the only thing that really messes them up.
I figured that just one long run of wire with those dangles coming down to designate or trap, if you will, different frequencies.
That's correct. Yes, more or less. Yeah, that's the stubs. Provide a tuning. That's a topic we could talk a long time on that one too. But they provide tuning essentially for the multiple bands. Yeah, and there's like 4 stubs coming off of this, one for each of the bands that it operates on, and they're cut to a proper length that provides an essentially an electronic filter kind of effect to allow the antenna to be tuned for each of those multiple bands.
Okay. It seems to me it's very simplistic and would probably be very easy to make yourself. Am I wrong?
Well, the thing that is not simplistic about it is that end feed point transformer. There's a matching transformer in this little box
Okay.
that is matched for the antennas, or multiple ones, I think, in the multi-band version.
Don't they sell those separately where you can build your own antenna?
You certainly can, if you've got the electronics competency and the confidence to do it. You can put together your own antenna, certainly. Bob, you had a comment, or?
I was just going to say, so Stu and I installed this antenna at my house, and we put an antenna analyzer on it, and we're getting ready to tune it. We didn't have to tune anything. It came perfect from L&R.
It really did.
And that's been my experience. I bought 2 other antennas from L&R, and I haven't had to adjust a thing. Their SWR is really good right out of the box.
Now, they're not cheap for a chunk of wire, okay? This multi-band EF quad that works on these 4 bands, $145. The single banders run anywhere from about $60 to $90.
The one I showed earlier on the spool was the one in the upper right there. The other thing to note is the wire is very flexible.
Yes.
It won't kink. It's meant to be strung outside and thrown in trees and stuff.
Yeah.
So it's not just a piece of wire.
So they're really good. They work really well. They're very efficient, and having that end-fed point is really convenient. I'll talk about that more in a minute.
How long is the wire?
I'm sorry?
How long is the cable?
Well, it
bottom
varies
one?
depending upon the band.
No, I mean that bottom one, how long is that?
Oh, here, Dan, do you remember how long that is right offhand?
It's pretty long. I was going to say 50 feet or 60 feet, something
I
like
think it's more, yeah, it's like 60 or 75 feet, somewhere in that range.
The one in the upper right is about 40.
Yeah, this for this 15 meter, for a 15
20
meter,
or 40
20
meters.
20 meter.
Well, the one by the 2040 is about 40 feet.
Oh, I've got that one here too. Here's the 2040 right here. Whoops. But
that. They
yeah,
have a good
same-
website. You can go on and look at it, and they get good details on the wire and all that, so it's worth reading.
Yep. So trimming these or tuning these, should you need to, for the single banders, essentially you just trim the end, and you'll see on that there's a little insulator on the end, and the wire is kind of wrapped back and forth in there, and you can just gradually trim that down as needed to tune your SWR. The other technique, and one I prefer, is you can route it through that insulator and then wrap it back on itself for a particular distance. That way you're not physically shortening the antenna with a trimmer, but you're physically shortening the antenna by wrapping that wire back and making the overall effective length less. So it works really well that way, but as Dan indicated, my experience has been, and his has been, that these things come from L&R Precision tweaked really closely and nice, and you may not have to do very much to get that SWR tuned up with these antennas.
Hey Stu, I think what you're paying for in this price is not the wire, though it's good wire, it's the transformer.
True.
Doing a low impedance to very high, this is a very huge impedance transformation ratio. And doing that with low loss is a technologically difficult task. And so I'm gonna guess almost all of the design effort and manufacturing quality goes into the transformer.
Yeah, I expect you're right.
If you're building your own, I would not just get a cheap Chinese transformer. I would buy a reputable
Elevation of
manufacturer's
that
transformer.
particular
Because
antenna.
you'll
We'll come
kill
in.
your performance if you don't do that.
Okay, let's press on. One other thing, conventional wire dipoles, you can also get these as single banders or multi-banders, or you can make them yourself. These are a little easier to make. I've made a number of dipoles myself. Essentially, your coaxial cable comes up and you have your center conductor routed to one side that's a quarter wavelength long, and your shield side routed to the other part of the element that's also a quarter of a wavelength long, so you get a half-wave dipole, single band. There are a couple of different varieties of multi-banders for dipoles. One is called a fan dipole. It looks like this. It's got multiple elements, and I have one of those up here that I just pulled down out of my yard after 8 years. And you're welcome to come up and take a look at it. I won't try to pass this around. It's been like beyond that, this particular thing is called an Alpha Delta DXCC. It's a fan dipole like this arrangement, plus traps. It's got a loading coil on the end of each element, like so. And what this does is that top wire, and you can kind of see in this image, is got a long wire for 40 meter band actually, and then you've got the trap, and 80 meters works on the entire length down to the insulator anyway. So that's what this coil is for. It's a loaded antenna for 80 meter band, and that gives you the part of the multi-band effect here beyond just the fan multiple length wires. But this antenna purportedly is designed for 10, 15, 20, 40, and 80 meter bands. You do need a good antenna tuner to work with 15 meter band with this, because it's using the same wire as the 40 meter with third harmonic effects there. So it gives you a little higher SWR than the other bands here, but with an antenna tuner you can certainly use it on 15s, a little less efficient, but it's doable. Some RF is better than no RF, as Shell told us earlier.
And it's really a narrow queue on 80.
It is. It's pretty narrow bandwidth for SWR bandwidth on 80 meters. So you kind of have to pick a part of that 80 meter band that you want to operate on, and with the low SWR, and your SWR goes up as you deviate from that designated point. But again, come up and check out this antenna. I do recommend it. It's a good antenna. It's lasted for a number of years in the top of a tree, in the top of a pine tree in my house. It's been blowing on top of Monument Hill, back and forth, and finally it broke a wire. All that motion finally ripped one of the wires or fatigued it, and it broke, but it lasted for a good long time. On a static pole, this antenna would probably last for decades.
I've got a shorter version of that at the XEE. It doesn't have the 80 meters, but
Right.
it's the same as 40 feet long total. I've had it up for 26 years. Haven't touched it.
Yeah, very sturdy, thick wire. It's good product. Here's one up on a pole. In fact, that's kind of what it looks like whenever you deploy it. So trimming this thing, tuning it for SWR, you have to tune each wire separately for each of the bands. So you've got the 10 meter wire on the bottom, 20 meter wire in here, the 40 meter wire, and 80 extension out there. So you have to tune each one of those uniquely in order to get your SWR trimmed down to the right spot. And they typically sell these long, so you have to trim them back. And again, you can use the wrap the wire back on itself technique, or physically trimming the wire with cutters. And about $160 for this product right now. It does have a center feed point. It's a dipole. Doesn't have a transformer on the end like these little wires that we were passing around. So you're probably going to have a little bit longer coaxial cable run to get up this pole or tree up to that center point. That's probably far enough away from your house that you're not getting some interactive effects there. Like,
I'm gonna throw a monkey wrench into your works. What about the
Okay.
use of a balun? What they used to call an ugly balun
yeah,
on your feed line going into that.
that is something with the time I have remaining, I don't want to try to go down that rabbit hole right now. This antenna has a balun built in up here,
Okay.
but I don't want to go down that path just right now because that's one of those topics that we could go a long time on.
We could combine it with the grounding topic.
Good.
Or Bill connectors in there
The
too.
weekend.
What I would recommend on that topic, let me just say that on that topic, I would recommend that you purchase an antenna that has that already integrated, and so that you don't have to worry. As a beginning station, which is what this topic is about, right? Your first station, buy an antenna like this or with the infeds that already has the balance unbalance situation worked out for you. And then when you want to go build your own dipole, and you can get into the whole balance unbalanced situation. Let's see, positioning, height above ground. Here's some nice, pretty red pictures. I wish weren't running off the edge, but you can kind of get the gist of that. As you take a horizontal dipole and you move it higher and higher in elevation above the ground, the radiation pattern changes because of reflections from the antenna to the ground, interacting with waves that are departing directly from the antenna and not reflecting off the ground. So the height above ground and the changes in those reflection angles and their interaction of the waves, their phase angles interacting, change the pattern of radiation that you get from the wire. So if you want to make contacts around the world, which one of these patterns do you want, do you think? I don't know if you can read those or not, but it says 1/8 of a wave, lambda is a wavelength, 1/8 of a wavelength high. So if you're operating on 10 meter band, then that's a meter, that's not very high, is it?
You want
Highest as possible.
You want us half or higher.
So which one do you, this is a quarter, a half, 5/8, I don't know what that says. 7/8, 1 wavelength high. So if you're on the 20 meter band, that's 20 meters high, 60 feet. That's getting on up there, right? So what do you think?
Half or higher.
Quarter wavelength.
Yeah. Well, the answer is it depends. My scenario that I just set up for you was you want to talk around the world. So if you want to talk around the world, you want your takeoff angles, the radiation angles, to be low to the horizon so that you can get a nice skip through with the ionosphere over the horizon. And so the height above ground that gives you the most power out toward the horizon is about a half a wavelength high. So if you're working 20 meter band, which works kind of throughout the solar cycle, and that would be popular right now, 20 meters, so half a wavelength is 10 meters. How much is that in feet?
33.
Yeah, a little over 30 feet, about 30, 32 feet, something like that. So that's optimal. If you could get a horizontal dipole or that end-fed wire about 30 feet high off the ground, you're going to get a nice to the horizon departure, the highest power going out to the horizon. Will others work? Yes, they will. And if you've got that low to the ground, you're going to get more of a bulbous sending energy straight up. And on some of the bands, some of those lower bands, you can get nice local communications, local being within 400 or 500 miles radius. Okay, it's called NVIS, near vertical incident skywave, another topic we don't want to dive down into. You also, for positioning, will need to consider accidental or unintended RF coupling with other conductors, like power lines or guttering and those kinds of things. This will affect your efficiency a little bit. You'll get some interaction, RF interaction with these other conductors as if they were another antenna element. And they will change your radiation pattern somewhat. Frequently, we just have to live with it. Some RF and some cockamamie pattern of RF is better than no RF at all. So if you have this situation, hey, it's okay. You can still do a lot of communicating, make a lot of QSOs around the world, even if you've got some things interacting a little bit with your antenna. And feed line length, for positioning your antenna, you're going to want to consider what's that feed line run going to be? What's my loss of the coax over that run? And where do I want to position the antenna? So those three factors kind of go hand in hand together. With an antenna tuner, I'll show you there's a lot of different types, many different products on the market. Here's a couple of examples here. You can get a cheaper manually tuned antenna tuner. You can get these fancy automatic tune. It's one button push and it automatically tunes up no matter what band you're on. And if you're going to use an amplifier, you need to make sure that you get one that can handle the power that you're outputting. So they kind of go up in price and those characteristics. Some multi-band antennas, like I mentioned earlier, this DXCC will benefit greatly from one of these, especially on that 15-meter band. And then a lot of difference in quality and features. Again, a topic we could go very deep into and look at a lot of different products. Bottom line is do your homework, study up a little bit before you go and purchase one of these. If you do a good job of tuning up your antenna, trimming it properly for length, and getting your SWR low, you don't even need one of these. Okay? But if you've got that multi-bander, you may have no choice on that one band but to use one. Additional considerations, here's that whole grounding topic in 3 minutes or less, right? Here's some good techniques. These are not absolutely required. Your radio will work fine without them. You may run into some things, some issues, but generally speaking, you're going to want to have a single point ground in your Radio Shack for all of the different boxes of equipment that you use. And you're going to want to ground the chassis of these things, your transceiver, your power supply, your tuner, other items that you may have in your station, to a single point, a single panel, or perhaps a pipe. Each one of these has a little strap going to the pipe, and then that routed to a ground rod in the earth. So tie the common ground point to an earth ground using the shortest possible run available to you. It's always a good idea to use these, and passing these around, be careful, there's some pokey edges on here. Copper strap, very low impedance because of that wide strap, the large surface area, and tinned braid like this, very common for use in mobile stations, but it can also be used in your base station as well. Additional considerations on routing is, let's see what I missed there. Oh, I missed this, didn't I? Yeah, there's as Bob likes to say, a really thorough example of a single point ground panel on the shack. This is from my station at home. Got a copper plate back there, copper strap coming from my equipment, the transceiver, the power supply and so forth, and running, it's grounded here, and then it's running out to a ground rod out through the wall. There's an AC surge protector mounted on there and grounded, as well as some lightning protectors mounted on that panel. We'll talk about those real briefly here in just a moment. But that's kind of what you might want to use, something like that. Coax routing, you can use feed-through panels on windows to get your coax outside. Here you can see there's a little ground wire coming out of there as well. You want to ground this panel perhaps with that common ground in your shack as well. And here's your coax coming from inside the shack, outside running to the antenna. You can also use an entry ground panel like this. I have one of these attached to my garage, similar to this anyway, with a metal panel in there, and you can see the coax coming in from the antenna, going through a lightning protector that's grounded to this plate, and then it runs on inside the house. Here's some of that copper strap coming out and going down to where do you think that's headed? Yeah, one of those copper-clad ground rods driven into the earth. And you can ground your antenna using this kind of situation by grounding the shield side of this cable here. And that's what these connectors do. They attach to the shield side of that coax, not the center connector, and it's grounded to this plate that's thus grounded to the ground rod in the earth. You can also use these clamp and rod arrangements like this, where you've got your copper clad rod and a clamp over it. There's lightning protectors bolted on or mounted on and grounded to this clamp. So you can run multiple coaxial cables through here out to your antenna. Very nice setup. Just talked about that. And lightning surge protectors, you can use them if you want to keep things connected all the time. They do a pretty good job of stopping reasonable surges that come down your antenna and into your shack. It will not, nor will anything, stop a direct strike. Okay, these are not going to stop a direct lightning strike on your home. But if your antenna is picking up a big surge from the RF that's put out by a lightning bolt, it'll stop this and maybe save your receiver from getting hit. So we'll pass that around. That's
Is that just gonna melt something in there? Is that how that works? Is that just gonna melt something in there, or what?
Yep, it's just like a
Like one of those
fuse. It's just a really fast fuse. A fuse at RF for RF frequencies, essentially. So with the grounding, here's that big picture again. You've got your power supply over here, your transceiver, your tuner, all routed with some of that strap of some sort to this common ground point. That common ground point is grounded to a ground rod in the earth. Your coaxial cable comes out of your transceiver, maybe goes through a tuner and outside to a ground rod, and like that ground rod clamp situation we looked at in the picture. You might have multiple ground rods. As somebody mentioned earlier, I got several of these that surround my house because it was also like a lightning mitigation system simultaneously, but a couple of ground rods is more than sufficient for most purposes. And then from there, of course, out to your antenna, in this case showing the end-fed wire. Any questions about that? I know that's a pretty quick and dirty treatment on grounding, but what this will help you do back here, this common point ground, this helps keep all of your ground voltage levels on all your equipment the same, so you don't get current running between your different pieces of equipment and causing interference or biting you once in a while when you grab something or touch something accidentally. So really good technique, keeps those ground currents the same across the board. And what this arrangement is doing for you is helping protect against lightning surges. So I had a couple of hands here. Let me get Lee first, and then we'll go back here.
Why couldn't you just, I know this is optimum, why couldn't you just take it to the copper pipe coming out of the ground for your cold water supply?
You can. There are some pros and cons of doing business that way. The biggest con is that if you get a really strong lightning surge coming through, it's gonna probably jump to other parts of your home.
Okay.
Instead of routing directly into the ground the way that you would want to dissipate that energy.
Okay.
And Troy.
Yeah, so the radios, transceivers have a ground point on them, usually I've noticed.
Yes.
But at least my power supply doesn't have a ground point on it. How do you then ground? I mean, obviously, what's the answer?
If you look at that Samlex supply that I passed around, it's got a little screw on the side with a it's on the right at the back, and it's got a washer on it. That's where I connect mine.
Just any screw on the
Yeah.
case, as long as I'm in the case.
As long as the chassis is connected there, you're safe. Okay, here are additional considerations in those references I told you about. So operating on HF with single sideband is a little different from operating with FM and on repeaters. So you can tune contiguously across the band. You don't have FM channels that you're working with. So here's a whole bunch of references for you from hamradioschool.com to look at, to learn more about operating single sideband and otherwise on the HF frequencies, HF bands. Solar conditions have a big impact on HF because of that ionosphere, the density of the ionosphere. You can learn more about that at these links. Polarization is pretty much irrelevant with those long distance weak signals, okay? Your polarization is gonna get twisted into a spiral as it goes through the ionosphere, so it really does not matter very much. And other information about antennas, I have a number of links there for you about various antenna types and considerations. Okay, so you can reference these charts on our website at W0TLM.com. And just click here and read about those if you want, or just go on the website and peruse our various topics. Okay, sorry I ran over 5 minutes, I know. Questions? 4 minutes?
No, I was gonna tell you 5 minutes.
Oh, okay.
I warned you.
You
I
did.
said he went long, so I'm not the only guy that went long.
I know, I couldn't go more than 5 minutes long, because that's how long Bob went before I cut him off. Mike?
Stuart, just thought I'd make a comment. You showed the copper strap and the braid.
Yeah.
The braid, my understanding is the braid is not now recommended for outdoor use because it corrodes and rusts. It's a great connection because it's flexible from your equipment to your panel.
Yes.
Which is usually outside or
Yeah,
halfway outside. But for the ground connection outside, do not use the braid, use the copper strap. Because the braid depends on continuity between all the fibers.
And when
all
it
the
starts
wires.
eroding,
It'll
it's-
corrode and erode and so you don't want to use that outside.
Yeah, that's primarily, that was really intended primarily for that, the single point ground in the shack, was the intent there.
Yeah, it's
But,
great
yeah,
for inside.
Yeah,
Yeah.
and also on mobile stations inside the car for bonding different parts of the car together. Other questions or comments? Going once? Going twice? 3 times? Okay, good. Let me extend to each of you, especially you new operators who have just recently got licensed through our class or other